Hello, everybody. Welcome to this tech talk at Decodable. We haven't done one of those for quite a time, so I'm really happy that we are doing it again, and it will be the first of a few more to come in close future. So really cool to get this going again. And today, this one is about a topic I've been really excited about for quite a while, and the team has also worked on for quite a while. And it's about how we actually, can ingest data out of multiple external sources into Decodable and take data out of Decodable into multiple external resources on the sync side. We call this multi-stream connectors. John MacKinnon, who is here with me today, he and his team, they've worked on this for the last few weeks and months. And this is what we would like to show you today because it helps a lot with, well, just reducing the operational complexity and also, just frankly speaking, cost when using those data streaming use cases on Decodable. So that's the gist for the session today. And now what I would like to do is I would like to give you a quick overview of what we can expect today. So just to bring everybody onto the same page, I will give you a quick overview of what Decodable is, what this platform does, and why you want to use it. I will also touch a little bit on what we have been adding recently, so some of the newer features. And once we are done with that, well, we will get to the main part of the session. This is about this multi-stream connectors feature, which I mentioned. And I will just briefly motivate it, and I will hand it over then to John, who will actually give you a demo. If you have any questions around all this, please put them into the Q&A chat of Zoom, and from there I will be able to pick them up and answer then hopefully some of those. All right, so who are presenting here today? So first of all, I'm Gunnar. I have been a software engineer here with Decodable for about 18 months. I work on what we call the data platform team, so dealing with Flink deployments and everything. And maybe you have come across my work before I joined Decodable because I was the lead for Debezium, which is a tool for change data capture. And it's one of the connectors which we have in Decodable for ingesting changes out of relational databases and other databases into Decodable. And I'm here with my great colleague, John MacKinnon. How about you want to introduce yourself, John?
Hi, folks.
That's it?
That's it. I'm a software engineer. I've been working on data platforms for a while in the startup space. Excited to be here. Excited to be working on these problems.
Awesome. John, thank you so much for teaming up with me on that. So let's get going. What is Decodable? Why you want to use it? Well, in a nutshell, it's a platform for real-time data movement and real-time data processing. So what that essentially means is it's about taking data from a variety of source systems, optionally processing the data, and then putting it into a variety of sync systems. So you could think about it as real-time ETL. So data movement. And the core thing of this is, or the exciting thing of this is, this happens real time. So with a very low latency from source to sync. And I would say what it sets apart from other platforms in that space is this optionality or this optional support for doing processing, so like filtering data, mapping data, joining, aggregating, doing windowing operations, all this on real-time data streams closely integrated with managed connectors. This is what is so unique about Decodable. So there's a very rich and wide ecosystem of connectors which we will support, or which we do support. I'm going to mention a few in a little bit. And now as for the processing part, well, most of the times people just use SQL for that. So you can use SQL to declaratively express your stream processing logic, so something like filtering or mapping or maybe joining multiple streams. All that can be done easily using SQL. But then for those cases where the powers of SQL are not enough, we also support the imperative APIs, which are coming with Apache Flink. So you can use the Flink data stream API or PyFlink to be more flexible in terms of how you express your stream processing logic. We also support that. And as I mentioned, it's a fully managed platform. So it runs in the cloud. It's a software as a service. It's charged by, by the hour. So it's a consumption-based pricing model. And all this means you don't have to care about scaling. You don't have to care about provisioning resources, tuning and allocating memory, keeping things up to date, keeping it secure. All this happens automatically under the hood, and you don't have to care about this. And as it's a cloud service, well, by default, people use it fully managed in our cloud. So you don't have to touch any infrastructure at all. But then sometimes there's a concern about data sovereignty. So people would like the data not to leave their own security perimeter. And this is what we support by a model called Bring Your Own Cloud, or BYOC for short, which essentially means that the data plane of Decodable can optionally run in your own AWS VPC. And in this case, we will still connect from our control plane to the data plane running in your VPC, but the data will never leave your security perimeter, which makes it interesting for healthcare use cases, finance use cases, and so on. All right, so let's drill a little bit more into this. And as I mentioned, it's a fully managed platform for stream processing. Now, internally, all this runs on Kubernetes. I guess that's not a big surprise. What's more interesting is it's a layer on top of this. So Decodable is based, and it's really standing on the shoulder of open source giants. So there's projects like Apache Flink for all the stream processing part. There is things like Debezium, close to my heart. As I mentioned, I used to work on that for a long time for change data capture, which is about getting data out of databases and reacting to data changes there in real time. And then also, we, of course, make use of Apache Kafka for just persisting data, making it replayable, and so on. And then on top of that, you have different means, as I mentioned, for interacting with those data streams. Could be declarative, or it could be more flexibly using, Turing complete languages like Java or Python. So that's the runtime side of things. And then there's sources and things, right? Of course, stream processing doesn't exist in a vacuum. You would like to do this on your data. And this is where source connectors come into the picture. So Decodable can ingest data out of streaming platforms like Apache Kafka, of course, like Apache Pulsar, Kinesis, but then also a variety of databases. This is where Debezium comes into the picture. So like MySQL, Postgres, Oracle is work in progress right now, SQL Server. So whenever data changes in those databases with very low latency, Decodable can ingest them, process them, and then put, for instance, the data into a data warehouse. So something like Snowflake, or something like Apache Pinot for real-time analytics, or maybe you want to do full text search on your operational database. So you would like to do something like, use something like OpenSearch or Elasticsearch. So that's a pipeline, very common use case in Decodable, taking data from MySQL into Elasticsearch, for instance. But then also there's like S3 support. So maybe you want to keep an audit log of your data and just persist events as they are as files, as Parquet files on S3 in a bucket. So you can get back to that data later on. That's also something which you can do. Cool. Now let me dive a little bit more into this platform, because what does it mean when I say it's a managed platform? So if you use if you want to do stream processing and operationalize all those components like Apache Flink, like Debezium, there's a large range or large number of things to take care of. So, for instance, you need to take care of state management. So if you want to do snapshots of your data or checkpoints of your data, where do you persist them? How do you make sure, you don't ever grow the space which is needed for keeping those snapshots? So you might want to do some sort of housekeeping. How do you optimize and tune those jobs? So how do you make sure like you efficiently, make use of the hardware resources you have to densely packed jobs, for instance, on compute nodes? How do you keep everything secure? Maybe you work with a larger organization and you have a large number of stream processing jobs, and now not everybody in your team should be able to access all the stream processing logic in your account. So maybe you would like to do something like role-based access control. How do you just go about schemas and their evolution and managing them? So things like a data catalog. How do you interact with all those connectors? So there's quite a few things which you need to address, or which you need to think of when putting stream processing into logic. And I mentioned some of those things which are shown here in those blue boxes. And this all the things in those blue boxes, they are handled by Decodable. So this is what we do. This is what we take care of in a fully managed way. So we take care of the infrastructure, we take care of the runtime, take care of all those aspects I mentioned. And then there's a unified REST API, which exposes the functionality to the users on top of that. And now, how to use this API? Well, you could use any REST client if you wanted to. So if you would like to do some, integration with your CI/CD pipeline. You can directly call the REST API, for instance, or to do some sort of automation. But also there's a powerful CLI, command line interface. And of course, there's a web client, a web UI, as we will see in the demo later on. So there's different means of how you can interact and work with Decodable. And now there's those 3 gray boxes at the top of this chart. And this is essentially the only part you as a user of Decodable would have to take care of, because this is where you put your actual logic. So this is where you describe, okay, how should my data be transformed? How should it be filtered? How should it be aggregated? This is what you express using SQL, or if it should be more flexibly, maybe you want to do some sort of external REST API invocation, for instance. This is something which you couldn't do in SQL, so you would rather do a Java or maybe Python job. Then this is something which you also can do. So only your core essential business logic, this is what you need to define, of course. I mean, we cannot do that. But then all the other steps, all the other infrastructure pieces for running this securely, scalable, reliably, this is everything what we do at Decodable. All right. So this is to bring everybody on the same page, what Decodable is and what it does. Let me just briefly, before we get to multi-stream connectors on the demo, let me just briefly give you an overview what is new, what has happened recently. And really, there has been a very excellent blog post by my colleague Sharon. You can take the QR code here on the right-hand side, where she just recently wrote about some of the recent developments. So I highly recommend to check this out. But to give you just the gist of it, so there has been many new connectors. So for instance, something like Apache Iceberg sync support. So people would like to take the data which they have processed and which they have ingested and put it into a data lake using the Iceberg table format. So this is something which we support now. There's a new SQL Server source connector. There will be Oracle CTC source connector. There is an S3 source, which is much more efficient than before, because it is based on SQS file notifications. So instead of regularly scanning your source bucket, this happens now based on notifications, which we ingest via SQS, the simple queuing service on AWS. And now this means it's more efficient and also more cost attractive. One thing I'm super excited about is what we call declarative resource management. So if you have been using Kubernetes before, you will be aware that this has a declarative resource model, right? So you say those are the resources which should run on my Kubernetes cluster in forms of custom resource definitions. And then Kubernetes takes care of materializing the resources which represent your intended state of things. And this is also what we do support on Decodable now. So you just say, okay, this is the state of essentially my Decodable account. So those are the connectors, those are the pipelines, those are the streams which should be there. You describe this using, of course, a YAML definition, and then the declarative API/CLI will take care of materializing all those required resources, or maybe delete them. So that's declarative resource management. And the other thing I'm really pumped about is the Python support. So many people have asked for Python support. So Python, that's the API in Flink for defining or programming Flink jobs with Python. And this is just very popular because Python has so many APIs, so many libraries, which allow you to do AI and machine learning use cases. So if you would like to, I don't know, just interact with your feature store, or maybe just employ some sort of Python ML library directly on your real-time data streams, this is now possible on Decodable using your own Python jobs, which you can deploy to Decodable, and then again, they will be run and executed fully managed by us. There's pipeline snapshot management, but again, check out the blog post with the where this QR code will take you, and you can read up on all those things in more depth. And also going forward, there will be more of those release announcements in a regular cadence going forward. All right. And of course, now there is one thing which I didn't mention yet, but which also was added very recently. And this is what we call, and this is why we are here today, what we call multi-stream connectors. And essentially, this is a thing which arguably you would just expect to have, and now we do have it. And it's about essentially just drastically simplifying how we can connect to external data systems. And this is about the source side and also about the sink side. And now here's a example for the Postgres source connector, which has now this multi-stream or MSC support for short. Now, in this case, it's about ingesting changes from 3 tables in a Postgres database. So table 1, table 2, table 3. And historically speaking, before we had MSC support, the way this worked was, well, you set up one connector for each of those tables. So you would have 3 connectors. And of course, this provides you, or this yields, operational overhead. You need to define all those 3 connectors. Frankly speaking, there's a cost implication because you need to run 3 connectors. And then also it just takes up more resources on this database because you also would have to have 3 replication slots, which is not ideal. And now all this changes drastically with multi-stream connectors because there we will have a single connector, which now is able to ingest the changes from all those 3 tables all at once, using a single database connection, using a single connector instance in Decodable, and then still fan out this data into multiple, what we call streams in Decodable. So that's in a nutshell, multi-stream connectors. And with that, I'm very happy to hand over to John, who will show us how all this works in a pipeline from MySQL to Snowflake. John, take it away.
All righty. You want to relink? Yeah. All right, folks. I'm going to show you a demo today. As we all know, demos are live and nothing can ever go wrong during these. So I feel good about this. Today I'm going to show you a basic use case of MSC. This is going to be a replication use case. We'll take data from multiple tables in a MySQL database that's already set up, and we'll spit them out into Snowflake, all using a single connection on the source side to read multiple tables and a single connection on the sink side to spit out multiple tables into Snowflake. So you can see here, this is the landing page of Decodable. This is what you'll see when you log in. We're not concerned with any of this. We're just doing that basic replication use case. So I'm going to go ahead and jump into the connections panel over here on the left. And you'll see here, these are other connections we've made for this demo account, but I'm going to make a new connection. So I'm clicking this new connection button on the right. And this is our corpus of connectors. Today, we're interested in setting up MySQL. So I will start there. And this is a configuration page where I set up the details on how to connect to MySQL. Like I mentioned, I have a database already set up, and I've got a shell connected to that over here. So I'm just going to copy the host from that shell, fill in the other configuration information. Let me find the secret. All right, so we've already set that up. I'm setting it up to scan from the beginning of each table. That initial means it's going to run a snapshot on all the existing data that's already in the tables to get all the historical data already there. And you'll see I left the database name blank. What that does is it's an optional parameter that lets us filter out the database that we want to see, the specific database that we want to grab tables for. I'm going to leave that blank, so we'll get all databases, and then I'll just select the tables that I want from there. So what this does is Decodable goes and it scans that remote MySQL database, the whole host, and it shows us what tables are available for us to use. Today, I'm interested in this inventory database. You'll see there's 5 tables: addresses, customers, orders, products, and products on hand. And so it goes and it scans, Decodable scans all those tables. I'm going to select them to say I want to sync them. And then I have the option to choose what the output name of the stream is in Decodable. There's a default, but today I'm going to override that just for fun and call it demo addresses, say demo customers, demo inventories, demo products, and demo products on hand. You'll also notice that there is a view schema button. And what that does is it shows us the schema of the external table. So it introspects that from the MySQL database, and it shows the external type and the decodable type that it's automatically mapped to. So this feature, this whole experience, what it does is it goes and fetches the tables, it introspects the types, and it automatically translates them to decodable types, meaning there's a lot less work on your end to get this set up, and a lot less room for error from manual input. So I have these 5 tables selected. I'm going to hit next. which just created the streams in Decodable for us. I'm going to call this not a webinar source. So I've named the source connection. I'm going to create it. And there we go. We have a MySQL connection. It is connected to 5 output streams that we just created. And I'm going to go ahead and start that so it can get going. I want to show real quick on the database side. So if I show databases, we'll see those same databases from before. Inventory is the one we're using. So I will use inventory. If I show tables, then again, there are those 5 tables that we looked at. And that's just what it looks like on the MySQL side. So while that is starting up, I'm going to go ahead and create the Snowflake sync that is going to push this into Snowflake. So now I'm configuring the Snowflake sync, and in a minute, we'll be able to select the streams that we want to use as input. But before I configure this, I want to show you our Snowflake setup. I have a database here called Decodable Demo DB, and I want to send data to that database. I'm going to send it to the, oops, I think I'm logged in as the wrong user here. There we go, webinar schema. Should have called it not a webinar schema, I suppose. I'm going to use my personal user, which I had previously configured. And finish out the rest of the configuration. Okay. And so what that does now is it scans our streams that are in Decodable. So these are all the streams on this account. I'm going to search for that demo underscore, which is what we call the output streams. You'll see we have our 5 streams that we created before, and then this other stream that happens to start with demo that's from a different demo. Again, we have the ability to override the name of the output table that's created in Snowflake and see the schema of the decodable types and what they're mapped to in Snowflake. So I'm just going to go ahead and keep the default names. You'll see there's no tables here yet. So I'm going to hit next. Oh, I think this is probably a permissions issue. Yep. So let me go ahead and make sure that I have the right permissions on that database. With demo role. And I want to be able to create a table. Oh, I want usage as well. I think that should probably do it. There we go.
Nice. So actually quite quick turnaround time for sorting out this sort of issue.
Yeah, it's almost like I've done it before. You'll see that there are these tables now that didn't exist previously. These were just created by that UI flow. And you'll see that they are created with those columns that were defined in that schema dropdown.
Nice. Okay.
Not a webinar sync. Fantastic. Then you'll see 5 inbound streams, which are the ones we just selected. I'm going to go ahead and start that. I'm selecting the earliest offset, which means that it's going to read the earliest record from the input streams, meaning it'll grab all the data that's already been sent in by the source. So that's going to take a second to spin up. You'll see we have this MySQL source is now running. And it's outbound to our 5 streams. So if I was to look at the customer demos, we have some of the data that's been flowing in. This is just a preview of what that data looks like. But it's exactly what we'd expect and what's in the other database. Right. So it goes from customers, same information, just flowing in real time into Decodable.
Right. And now whenever there was like a new customer or one would get updated or deleted, this also would be really quickly reflected in that stream, right?
That's right. Yeah. I'll go ahead and show what that looks like once we have it flowing into Snowflake, but it's going to take all the excuse me, it's going to take the data that was already in the table, takes that snapshot, it sets all that, and
Right.
whenever data is inserted, updated, deleted, it's
Exactly.
propagated in real time to that downstream Snowflake table.
Gotcha. And so while this connector is starting, so which are the connectors where we do have MSC support right now, and which are planned?
Let's see if I can get this right because there's a lot of moving parts. We've got MySQL CDC source, we've got Postgres CDC source, we've got SQL Server CDC source, and Snowflake Sync, I think are the four that are ready right now. We've got Oracle CDC source and SQL Server Sync in the works right now, and of course, many more to follow. That entire catalog eventually will be multi-stream.
Gotcha. Okay, that makes sense. And actually, there's one question from an anonymous attendee. That's interesting. Hello, anonymous attendee. So, and John, I guess you can already you can guess what the first question is. What will happen in case of source schema changes? So, if the schema evolves. So, what's the story there?
That's a great question. Yeah. So this is something that we are very aware of, right? In any sort of replication use case, schemas do change. What I haven't demoed today is a CLI that will accompany this UI for doing MSC work. And what that does is it pairs with the declarative resource management to scan resources, provide a local YAML file, which you can then apply, tell the code will make things look like this. And that gracefully handles backwards compatible schema changes. So we can't automatically fix backwards incompatible ones, but something like adding a new nullable column, removing a new nullable column, adding tables, removing tables, those are automatically handled by that CLI component, which you can then use and tie into your CI/CD
Right.
to automatically propagate changes when they come up.
Awesome. That's great. I think we need to do another tech talk for diving into that because I think it's also really cool to show. Cool. But so that's running now. So I think we can take a look into Snowflake, right?
That's right. So you'll see we're running 90,000 records have been sent. That should be everything. Move webinar stuff. Okay. And so I've got a worksheet over here. This is in Snowflake and attached to Decodable Demo DB webinar schema, which is where these tables are. I think I'm in the right role. So we'll see how that goes. So let's do a real quick demo customers. Seeing 92,900. Let's see if we get the same thing over here. Select star. $92,900. Great. All right. So if we want to look at from demo customers or by the just sending and limit it to the first 10. So you'll see we've got 96,703 is that max ID. I have another script that I'm going to run here in a separate shell window. And what this does is it inserts data automatically into that customer's table. Every few seconds, a new record shows up. And then what we'll see is that data is going to, in real time, get moved by that SQL or the MySQL source, read into Decodable, and then propagated into Snowflake. So give that a second to run, and then we can go ahead and re-query on the Snowflake side. And we'll see that the new records are showing up. Right. So previously it was that 703. And then now we've got new records coming in.
Right. Really cool. That's amazing. And there's a little bit of delay because there's some sort of staging period, right, in Snowflake. But it's like with a really low latency, right? So that's really cool. So thanks so much. Thank you so much for showing this. And now there is this other. Oh, by the way, did you want to show more here, or should we talk about multi-tenancy?
I want to show real quick just an update in how.
Oh, right. Yeah, sure. Let's do that.
So let's go ahead. We have 96708, the email here. Let's make that something else. So we'll update customers set email equal to 5. Webinar update. I have to put a lot of like dollars into the jar for calling this webinar.
Yeah.
96708. Okay, so that's updated. And then again, that's going to take a second to propagate. Equals 96708. Oops. There we go. So the email was updated
Nice.
right after we updated here. And that's it for the demo.
Awesome. Really cool
So let me
stuff.
go
So
ahead.
I think that's like really powerful to take this data. And I mean, you just did a little bit of relatively simple configuration and then mostly automated discovery. And then now we have set up this flow from those 5 tables. I mean, we just looked at the customers table, but it's 5 more or 4 more tables, right? So you have this end-to-end flow set up. And now there is this one little additional trick to that, which I find really fascinating and intriguing. This is multi-tenancy, right? So how about you tell us a little bit about how this works?
Yeah, so what we saw was a straight replication case where every table in the upstream MySQL ended up in its own discrete table downstream in Snowflake, and that's a great use case. I want to mention we didn't do any processing in the middle, which I think you said before, like there's a lot of power in that in Decodable.
Right, we could.
But being that we're only looking at the connector side, like we're just doing a straight replication for this. Another kind of more complex case for this is a multi-tenant replication use case where, for example, we had a customer who their upstream database or their upstream MySQL host is chopped up into a bunch of different logical databases, one for each of their users. And within each of those databases is the same set of identical tables. So this is a way of having logical isolation between users' data. But what you end up with is a ton of tables. I think this is on the order of a couple 100,000 tables.
Wow.
Which they wanted to replicate downstream into Snowflake and do analytics on, and join together and be able to run analytics on tables in mass. So what we did was we used that ability of multi-stream connections to rename the output stream of the tables to select the same output stream for every table. So for every table A that's being read by a connection, we had it spit out into that same stream A. And what that looks like is this. So you have many databases on a MySQL host, all with identical tables, which are then unioned and reduced down to the set of unique streams for the unique table shapes that are observed in that upstream host. And automatically we configured our MySQL source to inject the discriminator fields, so like the database that it came from, so that you know which upstream database a record is actually belonging to. And we were able to reduce those hundreds of thousands of tables down to just a set of 200 odd unique tables that are shared across all of the different tenants. So in that way, we were able to not only simplify the outputs so that we don't have hundreds of thousands of tables in Snowflake, but also save on the unioning and sort of downstream processing that was occurring anyway in their data pipelines within Snowflake.
Right. Yeah, really cool. I think, I mean, also within Debezium, I've come across exactly this kind of use cases, again and again, where people have the same set of tables within multiple schemas in their database or multiple logical databases. And this is such a common requirement that you would like to unionize, or union, I'm not sure what the right verb is, into the set of distinct tables into a data warehouse. And I think it's really cool that we do support that. All right, so I think that's it. What we have on multi-stream connectors. Could you advance to the next slide, please? Right. So just to wrap it up before we go to the Q&A, I saw already there's quite a few questions. We will get to them in a second. To wrap it up, so multi-stream connectors, as we have seen in the demo, thanks, John, great job for doing that. It is about, as we saw, right, taking data from multiple external resources, and putting that data into multiple external resources, but with just a single connector. So it is really makes this very easy in terms of operational overhead. As you saw, we set up a single connector. It did the schema discovery on the source side. It did the creation of the tables in Snowflake once we had the right permissions. It did all that automatically, and even it can do some sort of changes if there's an evolution to your schema there. So it helps a lot to reduce the complexity just in terms of running this and setting it up, but it also costs, right? So instead of having a connector for each of those tables or for each of those schemas, we have a single connector for all those 5 tables, as we saw. So that's pretty cool. Decodable, as we've seen, is at large is a fully managed software as a service for data movement. And today, this is what we focused on: really data movement, plain replication use case from your operational database into Snowflake. But then also using all the things I mentioned, like SQL, the Java Flink API, PyFlink. You also can do some an arbitrary amount of processing. So if you would like to filter the data you send into Snowflake, or if you would like to enrich it or modify it or aggregate it before sending it to Snowflake, this is also something which you could do. Cool. Next slide, please. All right. Yes. Call to action for you people out there. So definitely check out the Decodable website. There is, we have a blog with all kinds of interesting new posts there. You can try all this for free. So we have a free tier. If you go to app.decodable.co, you can set up the pipeline, which we saw today. In the free tier, there is enough resources available for setting this up. So we give you the ability to reproduce this with your own data right after this call. You could go and do it. Check out the docs. We just rebuilt our docs platform. So it's in a much better shape now, nicely searchable and so on. So that's docs.decodable.co. And then finally, we also have a YouTube channel. So I did a few videos there. Other folks like John, I think you also did a few things there in the past. And again, we will have more videos about Decodable, but also upstream Flink, upstream Debezium, so the open source projects we built on to just spread the knowledge about all those resources. So go to the Decodable YouTube channel. By the way, I realize people they don't know what this link is, right? But if you go to youtube.com and you just search for Decodable, the channel is what you will see as the first search result. All right, John, next slide, please. Yes, that's it. So again, free trial on decodable.co. I'm on Twitter, or I guess I should say X. Decodable is on X. And also, please feel free to reach out to John and me. Maybe go to John first and then to me, or the other way around, whatever. You can send us an email. We also have a community Slack. So there's quite a few, channels for reaching out to us if you have any questions around all this. Speaking of questions, let's see. There's quite a few questions, and I will try my best to go through them. And John, you will have to help me a little bit with some of them. So Gaurav is asking, for Postgres, does Decodable need replica identity full? I think it does not. So for the context, what does it mean? It's a configuration in Postgres, specifically how much information the while the headlock in Postgres needs to or should retain. So it's a function of size, but then also it means do we, for instance, get the previous state of a modified row for an update event? And I have not tried it, but I'm quite sure that we don't need full. So I would encourage you, take it for a spin, use the free tier, and try it out with a table which doesn't have replica identity full. And I think it should work. If it doesn't work, then let us know, and we can see what we can do about it. So we spoke about schema evolution. John, how about you take the next one from Shiva Prakash? And this is, where is data in transit stored while moving from MySQL to Snowflake? So where is that stored?
Yeah, great question. So that gets stored in Decodable. We manage that storage. We end up using Kafka to store the data internally. I don't think there's nothing intrinsic to it being Kafka. That just happens to be what we use. Change date capture data is stored definitely for replay if needed. It can also be, you can configure your sync to skip ahead, to ignore existing data and only pick up new stuff, or to restart, to backfill things. I don't know if I'm really getting to the heart of your question, but it's stored durably
Right.
in Kafka.
Yeah. I think no, I think that's exactly right. And in particular, it's stored and decodable, and it's also that way it's replayable, right? So let's say maybe you started and took your data as is, so as we saw today, as is unchanged into Snowflake, and then later on you realize, oh, actually, yeah, you would like to do some sort of transformation, cleansing, removing some fields or whatever from the data before putting it into Snowflake. So you could set up what we call a pipeline for processing this data, and then it could reprocess this data, which is stored in this stream. And you would start from the beginning and, then create another version of that data in Snowflake. So yes, it's stored in Decodable. So then there is one, if there is any lag, how can we handle that? And so I think, John, you need to help me out a little bit. But so the end-to-end lag, essentially, that's defined or that's impacted by what's called the checkpointing interval, as we have set this up in the underlying Flink jobs. By default, it's 10 seconds. But we have some customers where we change it, right? So if they need a lower latency, then we could reduce this checkpointing interval. So that's something which we do or which we can do for customers. And then, John, in case of Snowflake, there's this other delay which just comes by means of or by how this data is put into the staging area in Snowflake, right?
Yeah, so that's it's a complex answer for all this, right? For Snowflake specifically, we introduced an additional kind of warehouse merging interval, because as you know, Snowflake's not an OLTP database. There are no primary key semantics, so we can't just stream CDC data into, and work as upserts and deletes into Snowflake. So we allow you to configure an interval on which those changes are merged in. For the demo, I chose a 10-second interval, which lines up with that 10-second checkpoint interval that Gunnar mentioned we use in our product by default. But that's also tunable by you in case you need, really bleeding edge speed, or if you want to be more conservative on your costs and not invoke the warehouse that's used to achieve that sort of upsert behavior. So it's configurable, and that means.
Right. Exactly right. So there was another question which I actually skipped, and this is interesting. So it seems, again, anonymous attendee as said, it seems like the results sent to the output, so Snowflake in this case, is the same as what we saw. So does this mean that the output schema must be the same as the sync schema? And so this was the case, or this is the case for this plain replication which we did today, right? Because there all the data schema and its shape, it's derived from the source tables. So yes, in this case, this basic replication use case, then the schema in Snowflake exactly resembles the schema of your source tables in MySQL in this case. But it doesn't have to be that way. So if you would like to do some sort of transformation, so maybe you would like to just have a subset of your fields in Snowflake, or maybe, I know, you have some sort of weird date and time format in your source database, you would like to, modify this and have it like a proper timestamp in Snowflake. Or maybe you would, you have like something like an enum, which just has like numerical values in your source database, and you would like to convert this into like a string-based enum representation in the sync side. So all those kinds of transformations and many more, you can do them, and you would do that using by adding what we call a SQL pipeline, which you put then between the source and the sync connectors. So instead of going straight from source connector, stream, sync connector, you would add a pipeline in the middle, and then this would do all the transformation. And then, the data shape could be different in your sync system.
If I can jump into,
Sure.
that is currently the behavior where, you'll need to do that transformation in a pipeline, but we are actively working on the product right now to simplify that process as well. We're at the margins where you're on the connections and you're saying, does the table schema have to go one-to-one into the stream? We are working on simplifying that process such that for simple transformations, mapping, dropping columns, things like that, you wouldn't have to go through a pipeline. Instead, that can be handled at the connection layer. So the answer to your question is currently yes. At the endpoints, it does need to equal. But in the future, we're working toward a place where you can have a little bit more expressive definitions
Right.
for your schemas.
And until then, you could add the pipeline in between, right?
Right.
Did the Snowflake connector, so that's definitely for you, John, did the Snowflake connector perform deduplication in the demo?
It did. Yeah. The Snowflake connector is exactly once when you're processing CDC data. So they will always be deduplicated on the primary key of the input streams, which in this case corresponded to the primary keys of the input tables for MySQL.
Gotcha. All right, so that's on that one. And then another one from Garaf that's close to my heart. It's our toast columns handled in decodable CDC. So to provide some context there, so toast columns in Postgres, it's essentially larger text or blob values. And the way how you extract CDC data out of Postgres is done via logical replication, logical decoding. And now what happens is um, if there is a record which has such a toast column, and now the value for this particular column doesn't change, you won't get this unchanged value as part of change event. So for all other column types, you will get unchanged values, as long as there's any change to that row, you would get also all the unchanged fields from that row. But for a toast column, you wouldn't. You will just get a specific placeholder. And now this is, of course, not ideal because what you would like to do is you would always expose a fully self-contained event to a sync system like Snowflake. And actually, what I would like to do there is maybe I will just go and do it if I have some time to have a user-defined function, a UDF in Decodable, which would take care of that. So because such a UDF can be stateful, so it can interact with the state store, and then the idea would be if this function, which you then would add to a pipeline, to a SQL pipeline, if this receives an insert event, it would just put the value for such a toast column into the state store, and then when there updates are coming in for a table which has toast columns, then and we see, okay, this is an unchanged toast column, so we can see this from this marker value which the incoming change event has. Then we could go to the state store, retrieve the full value which we have stored before, and expose this downstream. So this is my long-winded way of saying right now the way you would do this would be with a custom Flink job you could deploy in Decodable, but going forward, I hope we can make this very, very simple just by having a UDF which you would then integrate into your SQL pipeline, and then it would take care of materializing the state for toast columns. All right, and then there's one more question, and this is what if there is retention policies on the source database bin log? Can we query the data itself without reading from the bin log? So all what we do, or the way CDC works with Debezium, which is what the connectors and Decodable use under the hood, this is based on the transaction log, based on the bin log in MySQL. So this means your database needs to retain the sections, the chunks of the bin log, which this connector needs to consume. Now, let's say you stop your connector for a week, and your bin log retention is just 2 days. Then you restart the connector, then this would not be possible because the database already would have discarded chunks from the transaction log, which this connector still needs to read. So in this case, then it would have to restart with a snapshot. This is something which the connector can do. It's an option when you start it. But what we generally don't do is what's called query-based CDC. So we will never go to the actual database tables themselves and query those for changes because, well, log-based CDC it's just advantageous, I would say. But yes, of course, you need to have some monitoring in place to make sure that you don't have a connector downtime which is longer than your bin log retention period. So those are all the questions. I don't know. I think, John, we are good. Any last words from your side? Greetings to your family or something like that.
I hope they don't watch this. Thank you everyone for showing up. Appreciate it.
Yeah, no, this was great, John. Thank you so much for teaming up. Thank you for the excellent demo. This was really fantastic. Thank you to all the people who tuned in. We also will put this onto make it available online so people can, check the recording later on. Again, you have different means of accessing us. So, feel free to bring your questions after this session is over. And finally, also, try, I just can encourage you to give all this a try by yourself. You can play with it in the free tier, and you can get a feeling for how this works with your own data within your own context of your own use cases. With that, thank you so much for tuning in, and I hope we will see you very soon again for the next Not a Webinar. Thank you so much. See you.